Jemma Rowlandson!
Wow, it's really, really bright. I can't see anything. You had one job. So, the title of my talk today was How to Save the World with Leerdammer Cheese. Now I know you're probably thinking, how the hell do you save the world with Leerdammer cheese? And 2 pints ago, I probably could have told you. But before we go into that, I just want to share like a little story from my childhood. Now, when I was younger, well, I think I had a fairly normal upbringing to begin with. When I was younger, me and my mum, every Wednesday evening, we'd sit down, turn on the TV and watch Midsummer Murders. Yes, I know, I can tell you exactly where to hide the body from the age of 7. But the thing is, at the time, Midsummer Murders was sponsored by Leerdammer cheese. See where this is going. Because, you know, nothing says buy my product like the chance of being hit over the head with a crowbar. Now, there are 2 unique things about Leerdammer cheese. The first is that, of course, whenever you buy it, you have a 1 in 5 chance of an early demise, especially if you live in midsummer. The second is more about its appearance. Shout out if you know it. What is different about Leerdammer cheese to every other kind of cheese? Go on.
Oh, disgusting.
Yeah, no. It's full of holes, loads of holes, and this is really important. As you may potentially have guessed by now, Leerdammer cheese at this point is more of a metaphor. I'm a scientist, we don't use metaphors very often, but it's a metaphor for anything with holes in, materials with holes in. And I completely forgot what I was going to say. It's really awkward. Anyway, Leerdammer cheese is a metaphor for stuff that has holes in. Now, to me, at the moment, holes kind of have a bad reputation. I mean, normally it's like, oh man, there's a hole in my shirt, or, oh, yeah, I've just fallen down a manhole, or even... happens more frequently than you might think. Even, you know, there's a hole in my heart. Yeah, you guys too. So maybe on a big scale, they're not so good, but on a small scale, on a molecular scale, they're actually really useful. And a great example of this is a fabric called Gore-Tex. Now, anyone ever have that urge to like climb a mountain? Yes? Great. Snowdon, Ben Nevis, if you want to go to university, Bathwick. Chances are, because you're in the UK, it's going to be raining, so you're going to have to wear a raincoat. Now, if you put on your normal Mac, chuck on your rucksack, start walking up the hill, you find for the first 30 seconds, and then start to get a little bit warm, a bit hot. And by the time you get to the top, you might as well have just not worn your Mac in the first place because you're going to be absolutely drenched in your own sweat. Lovely. Now, Gore-Tex can help solve this because it's basically a fabric filled with loads and loads and loads of tiny, tiny little holes. But these holes are really clever because they are small enough, they're small enough so water droplets can't come in, but at the same time they're big enough so water from your sweat can get out, which means that when you get to the top of the hill, you're actually going to be relatively dry, which is great. But can Gore-Tex save the world? No, probably not. No, just can't. But holes can save the world, and that's what I'm going to talk about. Before we get into the why, we're going to look at how. Now, holes are really good at 2 things. They're great at filtering stuff, like Gore-Tex, so let small things through, stop big things from coming through. And they're also really good at storing stuff. Like a reservoir is basically a giant hole in the ground that stores water, right? But holes at a small scale, they're really good at storing stuff as well, but they don't just store water. They can store other things like gases, nanomolecules, just anything you want, really. And they do this using a process called adsorption. Now, that's not absorption, which is what a sponge does. It absorbs water, but adsorption. I know, it sounds like I just said the same word twice. I have this issue. But I promise you they're different. And the best way to think about it is to imagine you're holding a custard pie. Now, in absorption, it's a process of taking something in. So like a sponge takes in water, you eat the pie, take it in, and it tastes delicious. Adsorption is slightly different. This time, you still got your pie, but you, or more likely, someone you know, and who probably doesn't like you very much, you take the pie and they shove it in your face. Because adsorption is the process sticking something on the surface. So absorption gets really confusing. Absorption, like a sponge, you take something in, you eat the pie. Adsorption, sticks to the surface, pie in your face. Now this is really handy because molecules really like surfaces. I kid you not. I mean, anyway, now normally molecules are they're kind of free-spirited, they just kind of like move around. Whether they're in a liquid, they swim around, and in gas, they just like float around until they see a surface, and then everything changes. And maybe it is the arrangement of atoms in the surface, maybe they're interacting with the atoms in the surface, but they just can't help themselves. Or maybe it's the jazzy pattern, but whatever happens, when they see the surface, they stick to it. And now I want to demonstrate how this happens on kind of a bigger scale, but I need some help. Can you guys help me? Yeah! So glad you said yes. Oh, this would be really, really awkward. So I'd like to ask my two assistants who don't actually know yet, but John and Sarah, can you please come up here. We're going to do a little experiment. So if you guys could hand these out to the audience, please.
Throw them?
Just don't hit them. You can throw them, it's fine. They're back. Okay, so some of you have probably guessed how this is going to go, but just wait for it, okay? So, we have our molecules. You're all holding them, please wait in the air. If you have a molecule, fantastic, oh, lovely colours. I spent most of this week sticking the Velcro tabs to them. So you know, I mean, doing PhD work, definitely. And now we also have a surface, which I'm wearing, my surface. So, and it's an experiment, so safety first. Let's go on. I know, you wish you had a pair. So I'm going to move over here to make it slightly easier. I'm only going to say this once. So when on the count of 3, please hit me with your balls. 3, no, 1. No, they're not aiming from me. You stand back. 1, 2, and 3. How about that unexpected? You guys can pick them up right now. So, as you can see, we have some molecules that have been absorbed. Hey. You're dropping them off. We have some molecules that have been absorbed. Molecules stuck to our surface, and this means we can store them, which is great. It's kind of itchy. Now, obviously, if my jumper is twice as big, or your aim is a little bit better, but we've just stored more molecules on the surface. So the bigger the surface, the more molecules you can store. Okay, and this is why our Leerdammer cheese material is so good, because they've got so many holes, they can store loads and loads of molecules on the surface. Probably more than this, guys. It's awful. Come on. Now, in my pocket I have such a Leerdammer cheese-like material. Now, this has a surface area, just the stuff in this vial, has a surface area equivalent to an Olympic-sized swimming pool. And that is because it has so many tiny, tiny, tiny little holes. See? How is it useful? Yeah. But now we know how we can store molecules. Why would we want to do this in the first place? Easy. Save the world. Yeah? So, how can we save the world with all sticking onto my jumper? So, the world, as you may have heard, the world's got a few problems. Yeah? And Gus covered them quite nicely earlier. One of the big problems is that 1.2 billion people do not have access to clean drinking water. That's almost a fifth of the world's population, and that's only likely to get worse as well. What we can do, if we put a Leerdammer cheese-like material in the way of polluted water, is that the toxic molecules, when they come along, they stick to your Leerdammer cheese material, and just the clean water passes through. Great, clean water, awesome. Another problem with the world, one of many, is global warming, which Gus definitely covered earlier. You all know about global warming, icebergs melting, polar bears in a little bit of trouble, just general doom, gloom, death and disaster. We want to avoid this if possible. So what we can do is we can go right to the source. A lot of global warming is caused by emitting carbon dioxide into the atmosphere. If we put our poly material where the carbon dioxide is being emitted, such as over a power plant, then your holy material will store the carbon dioxide on its surface, meaning that you can at least slow, if not prevent global warming, you can at least slow it down. Another fun thing to do with holes is to store hydrogen. Hey, watch it. Now, hydrogen is basically it's rocket fuel, and the great thing is you can power a car with it. Slight issue is it takes up a really big space because it's a gas. And if you actually wanted to drive your car anywhere useful with it, you have like a small blimp following your car around, which isn't really a good idea, especially as it's kind of flammable. What you could do is if you have a holy material, again you can stick your hydrogen to the surface of your molecule, and you can store it in a more compact space, which would be awesome. And so, carbon dioxide capture, water filtration, and storing rocket fuel. These are just 3 ways that our Leerdammer cheese-like materials of the chemical world can save the world. Thank you very much.
Well, let's for Jemma Rowlandson.